Okay, so now we're going to talk about power factor correction. Power factor correction. Yeah? So what happens is a lot of times in industry, when a power company wants to provide power to a factory, for example, and this factory has maybe an inductive load or such a thing like this, power factor is less than 1. Yeah? If the power factor is less than 1, that means, so if the power factor is less than 1, that means that the apparent power is more. If the apparent power is more, this is consumption of power that has no value whatsoever. But the power company must provide more current to compensate for this. And this more current costs money. Yeah. So what needs to be happening is that you need to correct this power factor. Yeah. So to correct this power factor, they usually put capacitor banks throughout the grid, and this sort of averages it out. So let's look at an example. And this would be example 2.3. So for example 2.3, suppose you have a voltage supply of 200 volts. Then you've got a resistor. You've got current flowing through here, I1, 100 ohm. And you've got another resistor, 10 ohm, 20J, capacitor. So the question they ask you is to standard find the total real and reactive power, the power factor to source, and the total current. So let's do that. So what do we need? So what you do is you just say, okay, it's going to be 200 divided by 100. That's 2 with an angle of 0. Also 200 divided by 10 plus 20J. What does that give you? 4 minus 8J. So to find total power, we say, okay, 2 conjugate of this one, because this is a current. Actually, we can find the total current. Total current is just 6 minus 8J. Yeah, so that's a total current. And the real and reactive power total, okay. So what you do is you can just say, okay, conjugate of this one is 6 plus 8J, and I multiply by 200, and I'm going to get 1,200 plus 1,600 J. This is the total real, total apparent. Yeah? Not apparent, reactive. Total real, total reactive. Apparent is the whole thing. Yeah. Find total. And then to find the power factor, you just look at your current. Current is 4 minus 8J. So all you got to do is say, okay, convert that into rectangular. 4 minus 8. Actually, 6 minus 8J, I should say. Yeah, so it's going to be minus 53.13012, because 6 minus 8J is the total, right? So this just means, okay, so if I want to find the power factor is defined as cosine of theta. This is theta. So the power factor is going to be what? Cosine of this. Cosine of 53.130. It's like 0.6, lagging. Why is it lagging? Why is it lagging? Because of this negative sign here. Yeah? Okay, now the interesting part. The interesting part is that in the next follow-up question, they say that, okay, find the capacitance value of the capacitor connected across the load to improve the overall power factor to 0.8 lagging. So how do we do that? Well, first of all, let's try to work backwards. So we say, okay, cosine of theta must give me 0.8. So what should theta be? Well, it should be cosine inverse of 0.8, right? 36.8697. Should it be negative or positive? Negative, because of lagging. Yeah? Okay. Now, the next step is you say, okay, I know that tangent of theta will give me q over p. P plus qj equals s. Graphically, it looks something like this. P, Q, S, yeah? So I can say that Q is equal to P times tangent of theta. It means that Q is going to be P, we found that. P, we said, okay, it's going to be 1,200. This is just the real component. Tangent of 36.8697, yeah? So Q is going to be 1,200 times tangent of 36.8697. 899.9, which we just say, okay, it's approximately 900. Now what you say is, okay, previously it was 1,600 for a power factor of 0.6. So you can say that 1,600, right? 1,600 minus, okay, here's that. We need the reactive power to be 900 if we want to satisfy the condition of 0.8. Okay, so you have to do 1,600 minus something x, and that should give you the value that you want, 900. So, and now we have to solve for that. So x is going to be 700, yeah, or 1,600 minus that. So now, okay, same thing. Okay, that's good, but I don't really know how can I relate that. Well, you can say that, okay, how do I find capacitance? Okay, well, I know that you can say that I know that impedance of a capacitor is 1 divided by 2 times pi times the frequency times the capacitance value. Yeah, so I can just say that the capacitance in itself is 1 over 2 times pi times f times the impedance. So if I can find this guy here, I'm set. I know the frequency is 60, right? So to find ZC, ZC turns out is the voltage squared divided by the apparent power. Why? Because voltage squared is like this. It's going to be what? Voltage squared is V times V conjugate. And if I take that answer and I divide it by S conjugate, right, this one here is going to be I believe V conjugate I. And so when you do that, you say, okay, it's V conjugate over V conjugate I. These cancel. V over I is just Z. Yeah? So what's our V? V is 200 squared. I apologize for the small space here. V squared over 700. We use the reactive component, and we're going to get what? 200 squared divided by 700. That's 57.14285. So that's ZC. Now I just plug it into this equation here. So you can do this on your own. You can say it's 1 divided by 2 times pi times 60 times 57.14285. You'll get some very small number like this one, 4.6 something. You just multiply that by 1 to the power of 6 because we want to convert it into microfarad. You say, okay, it's going to be this one. Yeah, it's going to be 46.42 microfarad. One last interesting point is that your new power is 1,200 plus 700J, right? If I divide that by, this is power divided by, Oh, my apologies. This is 900. This is my total part. 900, right? Right? Because that's what we're trying to get, right? X, which is 700, is just the compensation type of thing. It's the impedance. It's the power that is the adjustment to get to 900, right? So the actual power is 1,200 plus 900J. If I divide that by 200, I get 1,200 plus 900I divided by 200. That'll give me 7.5 amps. And what's interesting about that, I'm not calculating it for no reason, is because in the previous one here, we actually had, in the previous one here, we had 6 minus 8I. 6 minus 8I amps, right? This was our total current, you remember? 6 minus 8I was our total current. So I can convert that into polar form, and it's 10 with an angle of, we don't really care, it's minus 53 point something, but it doesn't matter. All that matters is that it's 10, right? 10 amps. 10 amps is much greater than 7.5 amps. So you see, the power company has managed to reduce the current it needs to supply because of the fact that the power factor has increased. And it's done this through adding a capacitor, and it's corrected the power factor. So yeah, it's pretty interesting stuff, and yeah.